11 billion years ago, monstrous black holes began crushing the very essence of star creation, altering the course of cosmic evolution. This groundbreaking discovery, unveiled by the James Webb Space Telescope's gaze into the distant Spiderweb protocluster, reveals a stark contrast. Galaxies harboring colossal black holes have ceased birthing stars, while others flourish. Prepare to uncover the secrets of this extraordinary find, poised to revolutionize our understanding of how galaxies thrive and ultimately perish. A team of scientists pointed the James Webb Telescope's near-infrared camera, at 19 galaxies inside a cluster known as the Spiderweb protocluster. This cluster sits an insane 11 billion light-years from Earth, making it one of the furthest cosmic neighborhoods studied in detail. By looking at these galaxies, researchers figured out that the ones with supermassive black holes at their cores seem to be running low on fresh stars. Meanwhile, galaxies without those gigantic black holes are still churning out stars. Yet, hidden within these galaxies lies a deeper mystery, a secret about the fate of entire cosmic realms waiting to be unveiled. Here's the thing about stars. They form when giant clouds of cold hydrogen gas collapse under their own gravity. As they get more and more packed together, the gas heats up until nuclear fusion kicks in, sparking a brand new star. This whole process gives off a specific type of radiation that clever instruments like the near-infrared camera can spot. The James Webb data helped scientists map this radiation, showing which galaxies are still making stars and which ones are slacking. Now, here's where it gets interesting. Astronomers have known for a while that older galaxies don't seem to be making as many stars as they used to. At first, they figured it was because these galaxies ran out of the cold hydrogen needed to make new stars. But then they noticed something odd. Some galaxies barely a billion years old were already slowing down their star factories. That's way too soon to be running out of gas. So what's the deal? Scientists started wondering if black holes might be the culprits. When galaxies merge, the black holes at their centers gobble up more and more matter, growing into giants with millions of times the mass of our sun. These black holes don't just sit there quietly either. As they feast on gas, they can shoot some of it out in super-fast jets. Think of it like a cosmic blowtorch, blasting away the very stuff needed to make stars. The Spiderweb protocluster is a great place to study this theory. Since it's so far away, we're seeing it as it was less than 3 billion years after the Big Bang, pretty early in the universe's history. And because it's packed with big galaxies and their supermassive black holes, it's the perfect cosmic lab for figuring out how black holes and star formation might be linked. Elliptical galaxies, the big round blobs of stars you sometimes see in space pictures, are known for having very little star formation. These galaxies are thought to be the result of big galactic smash-ups, where younger galaxies collide and combine. When that happens, their neat spiral shapes get wrecked, and their stars end up moving every which way. Plus, the central black holes in these galaxies merge too, creating even bigger black holes. Over time, these supermassive black holes can grow to become the heaviest ones known. When matter spirals toward one of these mega black holes, it gives off strong X-rays, which can be picked up by telescopes like NASA's Chandra X-ray Observatory. By comparing these X-ray readings with the star formation data from the James Webb Telescope, scientists noticed something striking. The galaxies with the hungriest black holes had the slowest rates of star formation. This isn't the first time scientists have seen hints that black holes might be pushing gas out of galaxies, but the Spiderweb cluster findings are especially useful because they show a consistent pattern across a whole group of galaxies of similar age. Out of the 19 galaxies they studied, 8 had supermassive black holes actively doing their thing, while 11 had quieter centers. Still, the team admits there's a lot they don't know. Other forces might be at play, and the relationship between black holes and their galaxies is probably more complicated than we think. For now, though, the evidence points to black holes being a major factor in whether a galaxy keeps making stars or not. One possibility is that black holes grow in bursts, consuming large amounts of matter during short periods of intense activity. These bursts could be triggered by galaxy mergers, which funnel gas towards the center of the galaxy, feeding the black hole. Another possibility is that some black holes started out much larger than we currently think, perhaps forming directly from massive clouds of gas rather than from collapsing stars. The James Webb Telescope's ability to look back in time is providing new data to test these theories. After learning how black holes impact stars, the next chapter reveals more findings from the James Webb Telescope. It's been 3 years since the James Webb Space Telescope hitched a ride into the great beyond, aiming to pull back the cosmic curtain on the universe's earliest days. Imagine building a device with the job of peeking back almost to the Big Bang. Sounds impossible, right? But that's exactly what happened. This high-tech stargazer isn't just here to snap pretty pictures, it's on a mission to figure out how stars, galaxies, and planets came to be and what happens when they're done for. One of the more eye-catching discoveries is the Sombrero Galaxy. Sure, it's got the name of a hat, but it doesn't really look like one. Still, cool nonetheless. Thanks to the observatory's mid-infrared tech, we got a peek at the smooth inner disk and some clumps out in the ring that regular telescopes just couldn't spot. Moving on, astronomers spotted a super-hungry black hole munching on matter like there's no tomorrow. This beast lives in a dwarf galaxy from way back, about 1.5 billion years after the Big Bang. And get this, it's gulping down stuff 40 times faster than scientists thought it could. In another mind-blowing find, Vega, one of the brightest stars in the night sky, got the spotlight. The telescope revealed warm dust glowing in the star's outer regions, while Hubble showed a smooth disk of fine dust. The kicker: there are no big planets nearby, just Vega chilling with a bunch of space rocks. Meanwhile, the observatory teamed up with Hubble to create a vibrant image of two spiral galaxies doing a cosmic dance, highlighting areas packed with star-making gas and dust. Then there's Centaur 29P, a space rock orbiting between Jupiter and Neptune. The space instrument caught it shooting out carbon dioxide and carbon monoxide jets. Think of it like an asteroid letting out cosmic gas clouds. Speaking of strange, scientists also found a galaxy from 1 billion years post-Big Bang where the gas shines brighter than the stars. Researchers believe this could be a key phase in how galaxies evolve. Now picture two galaxies crashing into each other. That's exactly what the Skywatcher captured in Leo, around 465 million light-years away. One's a spiral galaxy, the other an elliptical, and their interaction has caused the spiral's arms to get all twisted up. Heading closer to home, the instrument took a look at the edge of the Milky Way, revealing star-forming areas within molecular clouds. The images show massive young stars surrounded by swirling gas and dust. One of the more bizarre finds? A galaxy looking like a cosmic question mark. This funky shape is thanks to gravitational lensing, where a massive galaxy cluster bends light from something much farther away, warping it into odd forms. Early observations also spotted huge, bright galaxies from just 500 to 700 million years after the Big Bang, way too big and bright for their age. The culprit? Likely supermassive black holes boosting their brightness. Jumping to exoplanets, the stargazer observed a gas giant a dozen light-years away, with a temperature barely above freezing. It's one of the coldest planets ever directly observed. Then there's another exoplanet where one side always faces sunrise and the other sunset. Temperatures on the sunset side are roughly 300 degrees hotter, not what you'd expect. To mark its second birthday, the observatory captured two galaxies nicknamed the Penguin and the Egg in Hydra. Their ongoing collision, started millions of years ago, has warped them into these funky shapes. Another baby star sighting showed a protostar surrounded by an hourglass-shaped cloud of dust and gas. It's still in its early days, feeding on material to grow into a full-fledged star. The observatory also gave us an up-close look at the Serpent's Nebula, where new stars are being born. The nebula is filled with red streaks, jets of gas shooting out from these forming stars. Over in the Crab Nebula, which is supernova fallout about 6,500 light-years away, the Sky Explorer revealed complex filaments of gas and dust, along with regions where new stars are forming. Another twin baby star system caught scientists' attention. These stars, just a few million years old, are surrounded by gas jets shooting out in opposite directions. The observatory also found 3 of the oldest galaxies ever observed, dating back to between 400 and 600 million years after the Big Bang. These galaxies are still forming stars by pulling in helium and hydrogen gas from their surroundings. The next chapter dives into surprising new discoveries about galaxies and planets. The advanced eyes spotted WASP 107b, a puffy gas giant exoplanet that's missing a lot of methane in its atmosphere, hinting at a hotter core than expected. Meanwhile, another gas giant about 280 light-years away showed extreme wind speeds, clocking in at up to 8,000 kilometers per hour. In a jaw-dropping image of the Horsehead Nebula, which still doesn't really look like a horse, the cosmic tool revealed intricate details of the gas and dust interactions. Over in Ursa Major, a starburst galaxy was caught in the act of forming stars 10 times faster than the Milky Way. The instrument even detected alcohol in the icy regions of a molecular cloud, hinting that such molecules were around during the early days of star and planet formation. Heading to the Triangulum Galaxy, the observatory found over 200 young massive stars forming in a region about 2.7 million light-years away. It also provided evidence of a neutron star at the center of a supernova first spotted in 1987. Another quirky find? Some early galaxies look like pool noodles or surfboards, long, thin, and not what you'd expect. Over on Europa, one of Jupiter's moons, the stargazer detected carbon dioxide on its icy surface, suggesting it came from a subsurface ocean. And speaking of distant stars, the Cosmic Observer captured light from a massive star located 28 billion light-years away, the most distant star ever observed. Thanks to gravitational lensing, the star's light got magnified, making it visible to us. The Space Telescope also spotted a massive water vapor plume shooting out from Enceladus, a moon of Saturn. This plume stretches nearly 10,000 kilometers and likely feeds water into Saturn's rings. The device even gave us a detailed look at a mini Neptune exoplanet with a cloudy, steamy atmosphere about 40 light-years away. Among the coolest finds is a super bright infrared galaxy formed by 2 spiral galaxies merging. This event, happening 250 million light-years away, sparked an enormous burst of star formation. The instrument also captured images of Cassiopeia A, the youngest known supernova in our galaxy, showing off its expanding debris field. Jumping back to exoplanets, the cosmic instrument measured the dayside temperature of TRAPPIST-1b, a rocky planet around 40 light-years from Earth. Its scorching temperature suggests it doesn't have much of an atmosphere, likely leaving it barren and rocky. And in one of the flashiest finds, the device captured a massive star about to blow up. These Wolf-Rayet stars are huge, bright, and don't live long before exploding in a supernova. A deep field image of Pandora's cluster showed 3 merging galaxy clusters forming a megacluster, with gravitational lensing magnifying even more distant galaxies. Closer to home, the instrument caught a relatively small asteroid in the main belt between Mars and Jupiter. Nothing too special, but it shows that it can track down small stuff that could potentially hit Earth someday. One of the more dramatic sights was a dusty disk left behind after planets collided, captured in incredible detail by the Space Telescope. Another dynamic star-forming region about 200,000 light-years away in the small Magellanic Cloud showed abundant dust and hydrogen clouds, the building blocks for stars and planets. The stargazer unveiled previously hidden jets and outflows from young stars in the Carina Nebula, highlighting molecular hydrogen crucial for star formation. And in the Southern Ring Nebula, interactions between multiple stars created intricate, curvy shapes. Collaboration with the Gaia Observatory helped determine the mass of the central star before it shed its outer layers. In one of its more haunting images, the instrument captured the famous pillars of creation in the Eagle Nebula, emphasizing gas and dust structures without starlight. Another fascinating image showed a distant quasar surrounded by a forming galaxy cluster from 11.5 billion years ago, offering insights into early galaxy formation. The Sky Observatory also found a binary star system with at least 17 concentric dust rings, each formed as the stars approached each other every 8 years. These dust rings resemble tree rings or fingerprints, marking specific periods in the star's orbits. Finally, the observatory and Hubble teamed up to observe NASA's DART mission, where a spacecraft intentionally crashed into an asteroid to test planetary defense. The telescope also provided the clearest view of Neptune's rings in decades, revealing 7 moons and highlighting the faint Zeta ring. And for the arachnophobes out there, it took a high-def shot of the Tarantula Nebula, showing tens of thousands of young stars. Last but not least, the instrument captured the Cartwheel Galaxy, a rare ring galaxy formed by a high-speed collision, showcasing its bright inner ring and expanding outer ring where stars are being born at a rapid pace. Before we end, here's a question. If we can crash spacecraft into asteroids, when will humanity take its next giant leap? Like, comment your thoughts and subscribe for more.